Hello, hello, and welcome to another exciting episode of Skeptics and Seekers Sunday Sermon. This is 4S. I'm David Johnson, and let's get started with our very special guest, Dr. Greg somebody. I, I forgot his last name. We're going to call him Greg.
That works.
And we have got with us Matthew Taylor. We've got the one who wrote part of the science section in our response book, Still Unbelievable. That is one of the sections that not only did I not want to include in the book, I wanted nothing to do with writing it because I didn't think that we had the chops for it and I didn't think it was necessary. As it happens, we had a lot of chops for it. It just wasn't me. It was partly this guy. So, fun fact, if it wasn't for his insistence and some others, those chapters wouldn't have been in our book because I was against it. And so there you go. I am here now hosting a show with a freaking expert. Good Lord. Dr. Greg, that's the last time I'm going to say doctor. Please tell us who you are and why anyone in the audience should give a damn. I don't really care how short or long your introduction is. Just give them a clue.
Thanks for having me, guys. Yeah, I been a bench scientist for 17 years. My undergrad education's in evolution. My graduate degree is in microbiology using nanotechnology techniques. And basically, microbiology is the team I play for, but on the position on that team, I basically am a molecular biologist. So I change DNA around. I work with DNA and that we can create new strains, new types of organisms that have specific reasons to exist, like making more protein that we need, that kind of thing. And basically working at biotechnology companies doing that kind of thing from microbes and yeast all the way to algae and land plants. And about in October 2020, I started doing science communication outreach on the internet and kind of trying to bridge the gap between what happens in the lab and kind of the next generation truly science fiction stuff that we kind of do, Star Trek stuff in the lab, but none of that is being portrayed and communicated to the layperson, I feel like. And so I started that in October 2020 and took a little break to finish my PhD. And then, but about a year ago, I started up on TikTok doing a kind of like Ask Me Anything debate channel for a scientist. And people come up and they basically ask me anything biology related. Usually, because of what going through the pandemic, that's a large percentage of the questions. But also talking about evolution, those type of topics a lot. So that's what I do now every night. I have a night show.
All right. Wow. So what I heard was you are creating supervillains in a lab. That's what I got from that. Which is fine. That's fine because the villains we have right now aren't even worth hating. They're incompetent. So give us better targets, if you please. Matt, even though our audience knows who you are in this context, would you like to say something about yourself and your interest in science? You're practically a science communicator at this point.
I would not give myself such a lofty title, but thank you so much for this conversation, Greg. I read your email where you introduced yourself to David. Fabulous. I'm so glad you did that. You and I probably need to have a conversation as well, but we'll take
Sure.
that offline. I loved what you just said. What you said about microbiology is definitely something I want to have a conversation about. Definitely something that piques my interest. Definitely something I need and want to learn more about. In terms of my own journey, for your benefit, I'm a former Christian. I'm a former creationist. You probably already know exactly what all of that means. And it was the raw fact of evolution that got me out of that bubble. But I still see in my interactions online, in my interactions with Christians, there's a lot of traction in the apologetics community around your area of specialism, about I've forgotten the phrase now, about not being
Microevolution.
able. Yeah, the micro macro thing. Oh, that
Yeah.
bugs me silly. No, but it's about not being able to break things down to things break down not enough. I've completely botched up the way
Irreducible
that's the
complexity.
one I was after. Yeah,
Hmm.
that's the one that really bugs me. But I
You
need
see,
to
this
learn
is
more
why
about
I said you were practically a science
practically.
communicator.
Yes,
Yeah.
yeah. I'll
Yeah.
garble it, and then someone else who knows what they're talking about can translate it into English. Irreducible complexity. That's the phrase I was looking after. Thank you for getting me there, Greg. That's what I want to learn more about, or and I'm pretty sure from what you've said, you are the guy that I need to talk to about that topic. So let's try and touch that in this conversation. So that's where I am. That's why I'm excited about having this conversation with you, Greg, and supporting David in this conversation, because it was understanding, it was being hit with the hard facts of science that got me to change my opinion, got me to actually investigate it. And having seen some of your links and I watched half of your video with Kent Hovind.
Mm.
I applaud you for your patience because I don't have that. I have a list of people who I will not talk to because that will not be a pleasant conversation because I do not have the patience and the composure to be able to last that conversation. And Kent Hovind is one of those people. So well done. Congratulations. I had to stop it halfway through his first spiel because I literally could not cope. And you were being very calm and very measured and very factual. And I love that attitude and I love the way that that's presented. So you are a better science communicator than I am. So thank you. Let's learn about how to communicate better as well in all of this, because that's something I am also very happy to learn about.
Yeah. As for me here, I'm the theological guy. I suppose you would say a barroom philosopher, except I don't go to bars and I'm not a good philosopher. But at
Nice.
the level of, Norm from Cheers, no, uh, Cliff, at the level of Cliff Clavin for Cheers, I am a philosopher. so, so there you go. But everything touches theology in some way, because theology has branched out over the years, over the centuries. So it used to be a nice, neat, compact package that could stay in a particular domain. Poor fool Stephen Gould thought that it could occupy a domain and science could occupy a domain and everyone could get along kumbaya. I never bought that theory. I think that time only proves me more right and Stephen Gould more wrong.
Hmm.
Not that he's a bad guy or anything. You can't, these two, if you will, domains cannot exist together in the same space. They simply can't. Um, so I might bring a little bit of that to the table. But before we get into really having you do some presentation and question answering, uh, give me just the top level bit, whatever you're comfortable with, about your religious background, because that's going to always be a question. So, um, are you religious? Were you religious? Did you leave religion? What's the story there? How did you get from there to where you are now?
Yeah, I grew up Christian, non-denominational, just kind of just standard boilerplate Christian. I actually remember when I was a kid, one of my friends' parents being like, "What kind of Christian are you?" And I was like, "I don't know, Christian. I don't even know what that means." And I was like, "Wait," it was kind of like the start of this kind of like unraveling process of me of like, "Wait, I'm not even good enough if I'm a Christian now." Like, it was a very weird moment. And then basically I was always really interested in how the world works, how the processes that, came about and how we see like why are honeybees shaped the way that they are, stuff like that. And it was just less and less interesting over time going to religious answers, to the point where I just kind of, in my early 20s, went from, I would say, like in my teens, I kind of went from I'm not, um, I'm not religious. I'm like spiritual or something. I'm like a deist or something. I'm agnostic, as I thought the term was, before. And then really in my early 20s, just realizing that I don't really need this anymore, like just embracing agnostic atheism. I do call myself, in the stream and in debates, I do call myself a Christian atheist, because I do like espouse the virtues and the teachings of like Jesus Christ of Nazareth, and the fact that we should be like feeding the poor, looking out after one another, loving thy neighbor. I feel like that is like the truest form of patriotism and community building. So I try to embrace that, and
Mhm.
that part of my past, that my upbringing. And uh but but I don't believe that there is a God, as on the Dawkins scale, as much as I don't believe in a God as much as I believe in unicorns and leprechauns. So firmly.
Okay, you were mentioning the shape of honeybees. At what point in your curiosity did, well, God did it, stop being the answer? Because
Oh man.
that had to be the answer for you at some point, and then at some point had to become less and less the answer. So how did
That
that
was really
happen?
never that was never satisfying to me. That definitely happened as a child. I remember asking, I mean, we're talking like single digits, like talking to my pastor, being like, yeah, but like dinosaurs are cool, like what, like,
Hmm.
there has to be something that created all this, and it can't just be, the snap of a finger, so I remember asking my pastor about that really young. So I that was never really something that was that satisfactory for me.
The last time I was at a church camp I don't remember if I was a counselor or a assistant director, but something like that. It was a camp that I had done a lot in my childhood, and I kind of moved into leadership in that camp. And so a friend of mine and me, we both had history with that camp. We went back to the camp with one of our good friends who was one of the leaders of that camp.
Mm.
And but this was after we were no longer believers. No one knew that at the time, but we were supporting our friend. He asked us to come, and we decided to come along. And that camp was devoted to young Earth creationism. There was a Ken Ham style module that talked about dinosaurs and humans being around at the same time. Because so here's the thing: I could go into a church now and preach a sermon, a biblical sermon, without violating any of my ideas about God in the religion. I'd never have to say I'm an atheist, but I also never have to say anything good about the God. I can tell Bible stories and in such a way as to relate them to the real world and give good messages. I can do that today. And I am one who you could qualify as an anti-theist. So I could do that now. But being in a camp full of kids, and this was some years ago, with the theme of YEC, that was one of the hardest things I have done. Because I was no longer a yecker at that time, of course, because I had grown a brain. And my friend and I, we would talk about this stuff during the breaks and such, and we're like, what are we gonna do if some kid comes up to us and asks us about this? what are we going to do with this? And so
Yeah.
that's one of those subjects, one of those topics, one of those areas where, for me, there's no compromise. I can't say, well, we're not sure. The science is still. I can't say that. So I guess that's enough backdrop. For whatever reason, YEC. When I say YEC, I mean young Earth creationism.
Mhm.
YEC is making a comeback on the tubes and the talks. I have no idea why. I don't. I don't know why it's such a topic right now. And what I would like for whatever time we have left is for you to just tell me, from a science perspective, any domain of science will do. Every domain of science will do. Whatever part of the science is, tell the audience why YEC is stupid. But I'm also going to give you one surprise assignment. And
Okay.
you can do this in any order you want. But the surprise assignment is, give us, in your opinion, the best argument for YEC. Still man their position and think about the various things they say. What's the best line of argumentation they have? Now, with that, I'm going to go pretty quiet
Mm.
and I'm going to turn the floor over to you and Matt.
Go for it,
Um,
Greg.
okay. So I do think that we are seeing a rise in young Earth creationism. I see it a lot right now in my debates, and people talk about it because they have this mystical view of human health that was like pure. There was a period of time, you know, before microplastics and electricity that's surging through us that has, creating all these maladies and giving all this disease and harm to people. So now they kind of yearn for this time before. And so a lot of times they'll look towards young Earth creationism because that's a time when supposedly humans lived until 900 years old. So in their minds, if humans were living until 900 years old then, and then now we only live until, what median age is like 85, wow, that's a huge decline. Like, why? Oh, it must be modernity, right? It must be all these things that are surrounding us. It must be vaccines. It must be medicine. So you have a conflation with conspiratorial thinking around health and RFK and the MAHA, Make America Healthy Again movement. And this pseudoscience stuff around kind of like rosemary tinctures are going to help you battle measles and not vaccines. And then you have people saying straight up that like viruses don't exist. Viruses just don't exist. We don't need to take vaccines because viruses don't exist. And then you go to the other end where eventually you get to, well, yeah, it's because of young Earth creationism. Basically 900 people were living all this time, before all that, and that's what we need to go back to. And like obviously, that's just not true. 150 years ago, 200 years ago, people lived a median age until about 35 because of viruses and the microbes. The microbial world was taking the best of us. Basically, vaccines and antibiotics led to a huge decrease in childhood mortality rates. So basically, 50% of children used to die before the age of puberty. Like this was back thousands and thousands of years. And then basically 120 years ago now, antibiotics and vaccines kind of came in together in tandem and along with, washing and germ theory and all these things to let us understand that, oh, infection is a real thing. Microbes and pathogens exist. So we need to, holistically kind of take charge and battle against them. And that's why we've seen such a huge decrease in childhood mortality rates because children are the most susceptible to viruses and the pathogens and stuff, and antibiotics and vaccines help those people. So that's just the reality of the case. young Earth creationism doesn't account for any of that, right? Young Earth creationism, Noah's Ark story. I mean, this is the thing that I asked Ken Hovind. Nobody really understands. Like, if you have two of every animal in the Ark, you have to have every single like virus of every single animal inside of the ark as well, don't you? And all the microbial species in the entire world. Like we haven't even cultured or sequenced 99.9% of microbes. Like is Noah really going to, scrape the bottom of the oceans, in order to culture those microbes? Like it's just so laughable, it doesn't make any sense. The bit, I mean, obviously, as a molecular biologist, I'm really uh, DNA is kind of like what I think about as the best evidence, and endogenous retroviruses really are the death knell for any of this stuff because basically in a population you have specific ones getting targeted with this virus that has like an RNA to DNA component. That DNA gets uh, integrated into the genome of an organism, and all the lineage and all the descendants of that organism are going to have that unique viral thumbprint, right? And that viral thumbprint is going to accumulate, uh, you know, DNA errors based off of DNA polymerase rates that we know through molecular biology. So it kind of is a time clock that we can look in our genomes and watch, like, okay, not only did this lineage happen, but now, the time clock, and you can create those mutations and put it on a map. It's called phylogenetics, and you can kind of just see how everything is connected, so that all primates kind of share the same endogenous retrovirus thumbprint. We can watch this go through evolution, and it really is the best tree that we can kind of map, because basically 2% of our genome is codes for proteins, which isn't, for from a genetics aspect, like that's not the most important bit. There's a lot of regulatory things outside of it. About 20% of the genome is what we can understand, like map direct functionality to. But yet 8% of our genome is actually fossilized viruses. So so the idea that like a god is going to have to go through and specifically pick out portions of animals and put ancient viral DNA genomes in their DNA and do it maliciously over time in order to deceive people. If that's what people are going to believe, I guess that is what they believe. But I do think that the time for these kind of being esoteric, fun debates is kind of like over. 20 years ago, 25 years ago, this is kind of like, did Bigfoot exist? Was the Earth, 6,000 years old? These are um, interesting debates at that time, but right now we have such a sway into pseudoscience and anti-science belief that we're actually seeing people lose their life because of vaccine hesitancy, because of people not taking science seriously. So now I think is the time to actually fight back against this stuff and really push this down and say, this isn't an esoteric argument anymore. You guys are doing harm to one another. This is what I tried to say in the Kent Hovind debate, that you're actually harming people and blood is on your hands by pushing this stuff. And I asked him, just Kent Hovind, like, you are this young Earth creationist that says that humans are 900 years old. I'm giving you the space. You are not a physician. You are not a medical expert. You have no idea whether or not humans can actually live 900 years old. Just say that you're not a medical expert. And he said he wouldn't. He wouldn't say that. So,
Wow.
these people are, it's very dangerous. And in terms of the best possible young Earth creationist argument, would have to be some type of like God of the gaps kind of thing, where we just don't understand what's going on in the things that we don't understand. So it'd have to be like, we live in some type of simulation that's outside of our comprehension or something like that. I really don't, to the point of like 6,000-year-old Earth world. I don't think that makes any sense. I mean, you can literally just count the slices of ice core samples, and it's like 800,000 years old. Just like, it doesn't even require radiometric dating. It's just counting up to 800,000. So that's a little hard, but maybe God of the gaps in order to explain the other parts.
I think the God of the Gaps is really attractive because we like certainty as human beings. We love
Yeah.
certainty, and not being able to see an answer. It's very tempting to insert our preferred God into that shaped hole. I'm pretty sure that I was guilty of it, and I see it so much in everywhere I see about people pushing God. There's so many questions I want to ask you, but I can we go with the vaccine thing, because I'm seeing a lot of that in my social media feed. It does feel
Mhm.
that it'll be interesting to see if you agree. I feel like there is a relationship between conspiracy theories and the extreme young earth fundamentalist sections of religiosity. There certainly feels like there's a relationship between those types of viewpoint. And I'm with you. You know, vaccine hesitancy does cost lives, and the whole association with autism. I can't believe we haven't buried that. You know, why do ideas like that propagate? Is it purely because Russian media accounts are just spreading chaos for the thrills, or are there people who actually have some invested um, income or experience in trying to push these ideas out? Do people really believe what they're pushing about vaccines at some points?
I mean, I think that the it's tough. I mean, RFK, I don't think that actually believes that vaccines are causing well, harm, right? Because he could ban them right now, and he could just ban the vaccine. If he's said in his congressional testimony that he thinks that the vaccines actually killed more people than COVID themselves. So, I mean, COVID, the United States did uniquely poorly in throughout the entire world, and we lost 1.2 million people because of that. So in order, if there's 1.2 million vaccine deaths, like he has the onus in order to just ban them outright, and he doesn't do that because he knows that he makes money off of the lawsuits for the pharmaceutical companies, and then two, it's just the data doesn't put any weight on that. But what we do know is that we lost 300,000 people because of, and this is from posthumous epidemiological studies from New England Journal of Medicine and The Lancet. Um, 300,000 people due to vaccine hesitancy in the United States, and 300,000 people to uniquely poor decisions by the Trump administration during the pandemic that made more people lose their life than needed to. So those two things, like those are half the amount of deaths, you know. So it's uniquely very sad. But I think what's happening right now, and my theory of the case is that basically algorithms are figuring out who is conspiratorial, and maybe not even conspiratorial, skeptical, or has an honest question. Maybe it really is a genuine sense of like, what is this thing that I'm having done to my child? And you put that into the search algorithm, and then now you're flooded with AI assisted kind of like a wiping of your free thinking. Your critical thinking is kind of being given and offloaded to these AI systems that get these algorithms that give you conspiracy after conspiracy. And it's I've never honestly, and I've debated probably like 600 people now, through the TikTok thing. I've never seen anyone that has just a single conspiratorial belief. It's everything. It's everything all together. We call it the list. So I'll ask this, and people will believe all, like one or usually all of them. Germ theory being fake, immune systems being fake, the SARS-CoV-2 leak from a lab, the moon landing's fake, space is fake, it's a projection, flat Earth is real, 6,000-year-old Earth, gravity is fake, evolution isn't real, dinosaurs are fake, climate change is fake, vaccines aren't safe, we live in a simulation, plate tectonics aren't fake. Like it's just all these things that you're just like, why? And it's because these algorithms push this stuff to people because it's a lot easier to think that oh, isn't it a coincidence that the virus came from a Wuhan Institute of Virology? Like, isn't it a coincidence that that place like it exists? versus, okay, this is population genetics. This is what PCR is. This is what molecular biology is. This is, the CDC and the EPA, like going through and doing population genetics of bat caves next to Huanan, and figuring out that these are all the building blocks that are needed for the SARS-CoV-2 genome to recombine inside of a separate host that then is outbroken at a wet lab, like, I mean, sorry, wet market. Those like things, like all, that story is a lot harder to tell, and it's not going to be told in a 30-second TikTok, but someone being like, wow, dude, isn't it wild what they're keeping from you? And conspiracies in a way are kind of sexy, right? They're kind of like just a little bit of information that you need to know, and now everything is all called into question, because if scientists think that SARS-CoV-2 is manufactured in a lab, then why couldn't they have made all viruses in a lab? Why are viruses real at all? And that's the real scary part, is that it's a foundational belief now that once the scientific global cabal is working together against you, now it's like it's any xenophobia that you can just put into that, right? It's science, it's immigrants. There's tons of different things that you can put into that, like us versus them mind trap that people get into, and they get pushed into that. So I do think that there's some science education that we need to do to get out of it, but also we need to do something in order to get back like reality from these algorithms.
I'm gonna just butt in here real quick, and then I'm gonna shut up again. When you were talking initially about young Earth creationism and the various evidences, I wanted to follow up with that. Do you see any any space to give credibility to evolutionary creationism? In other words, creationism in its best form, which is to say, well, God created via evolution. And so you can bring all of the story of evolution into it, and you don't have to be a whack job. But you still believe in ultimate creation. Is that a possibility for the Christian, or does science cut that off as well?
I mean, it's tough because there's no evolutionary end goal, right? The problem with that idea is that there is this staircase and humans are at the end of it, and that's just not how evolution works. Evolution happened for 2 billion years at the prokaryotic level. We actually, by cell count, sometimes like we have more microbial cells in our body than we have human cells. So is God a microbe then? Like there's just weird things like that amalgamate. If God made us in His image, maybe it's the microbe part that is the thing that's our image. I don't know.
Mm.
It is again, like you could have like some God is dead argument where He created the world and then kind of like either died or is completely hands off at that point. But that doesn't mean that humans innately evolve on Earth. That just never could be the thing. Like dinosaurs may never have gone extinct, and we just mammals stayed at the size of a squirrel for millennia more. There is some like randomness to it, and the endogenous retrovirus is a good case for that, where you're you're really not only you're not having to have a hands-off creator at that point. You have to have a hands-on creator that is maliciously putting these things into groups of organisms' genomes, these fossils, these remnants, the DNA remnants that don't need to be there, right? There is no reason to have virus fossils in our genomes, and versus primates, or some groups of us have some of it and some of us don't, because it doesn't give us any function to be the organism that we are.
So you're
So
saying if evolution, assuming evolution, there's no evidence of any straight line from that to this, as if there were a particular goal. Uh,
Exactly.
I've always wondered that myself. I mean, for the Christians who believe in evolutionary creationism, then the conversation is just about the, did God have a reason for creating and that sort of thing. But for
Hmm.
me, it's always been evolution is sometimes one step forward and three steps back, and then five steps forward and a step back, and three steps forward and 10 steps back. It's not a straight line to anywhere. And where we're going, evolutionarily speaking, is equally a mystery. You can't take where we are now and then determine where we're going to be 10,000 years from now. So there seems to be no path suggesting any kind of directionality, from one place to another. I've often wondered also, and then I'll throw it back to Matt here. If creationism, what is the goal? What is the evolutionary goal? Because the goal could have been proto-humans. It could have been Homo erectus. Why wouldn't that have been the goal? Or the goal is, the first modern Homo sapiens, what, a couple 100,000 years ago. Maybe that's the goal. Maybe, but Christians tend to think we are the goal. Whatever we are now in our society, our situation, give it a couple thousand years, which is nothing in evolutionary time. This period, this brand of human is the goal. And they don't think at all if we are around as a species for another 10,000 years, 100,000 years. I don't think it's going to happen. But if we are around that long, we're not going to be us. We're not going to be like this. And so maybe the goal of God is some version of us 10,000 years ago, and we're just the bumbling idiot proto humans that need to be here preparing for the real humans that the drama plays out for. So,
That's
yeah, at any rate, that's my Cliff Clavin on that topic. Matt, take it
I
away.
agree. I think that's a really good point too. I mean, because we are like Homo sapiens are a hybrid species, so we are a hybrid of Neanderthal and Denisovans. So we interbred with them. So if the same logic applies to Homo sapiens, then the same logic should apply to Denisovans and Neanderthals, right? I mean, were they God's chosen people too, you know. And that's my whole thing with souls too. Like, I feel like people spend so much time like looking at like religion, but in reality, I think that the real mind warp thing is souls because people get this idea that there is this supernatural thing that exists inside of your brain because we exist in this kind of like theater position with our eyes looking out, and there has to be something else here. But in reality, it's just we're, a ratio of neurotransmitters in our brain that kind of exists in the world. And if you other, you know, mind altering substances, you can see very quickly how your, that view of the world can come crashing down very easily. So the idea of this or Homo sapiens kind of being the goal. I mean, that's a really good point. I totally agree with you. And consciousness and is a lot broader than we think. Every single time we've tried to, stay, the line is this, and humans are uniquely good at this thing, and then crows start using tools.
Yeah.
Then mammals all over they have matriarchal societies and cultures, generational stories that they tell one another. Stuff like that. Where we're wrong every time when we try to say this is uniquely human.
Fish make prettier patterns on the seabed than I can draw with a pen and paper. Frankly, let's just put that out there.
Yeah, exactly.
Yeah. S- I have a question about. I'm going to stick with vaccines for a minute. I know we've meandered a bit, but I think it helps stay us
Yeah.
on top because you said about genuine questions. And I think one genuine question I do see about vaccines, which I think is a valid question, But unfortunately, I think the assumptions behind the question spawn a lot of bullshit.
Mhm.
So the question is, the COVID vaccine, all of them, were developed in a very compressed timeline. And I'm sure with our science minds on, we can explain why that happened. For those who don't appreciate the way that part of science works, and for context, part of my job is in my job is IT, and part of my previous life in previous jobs, I've actually done document management systems for pharmaceuticals. So I have some familiarity behind the work that it goes to putting a new drug onto market. And I know it's a bucket load of work. So I was impressed with how quickly the COVID vaccines came onto the market and how quickly that came through. It was shockingly fast. But needs must. There's nothing better for human invention than an absolute pressing need. But why are we seeing a link between that question and the conspiracies that are related to the COVID vaccine? And how do we break that link? How do we go from explaining that compressed timeline to it's not a big conspiracy?
Yeah, so the basically how vaccines are a small part of a viral particle that your body is exposed to. It learns the antibody, that binds to it, which allows your body to store that information, allows your body to make more of those antibodies. Now, your how we introduce that piece of that viral fragment before, we would use inactivated viral particles, or we would use ways of through evolution. So basically, we'd create a strain of the virus that has the similar shape of the original virus, but that just doesn't kill the host. So that's a live attenuated vaccine. Then there's the heat inactivated one, or you can chemically do it. But this other alternative was really, since we've been doing molecular biology and we actually can deliver DNA that has a specific sequence, the question is well, those other two things, they can change over time. The hand that that's on the outside, the little handles that exist outside of the cells that your body learns to attach to, that can actually kind of change through that directed evolution approach and through the inactivation portion. So what we really want really is a fresh copy of the virus at exactly the same sequence that we want to be inside your cell right then and there. So as molecular biologists, we do this all the time. We introduce DNA to RNA to proteins, and the idea was like, well, why don't we just do that inside of the cell? So this has been done since 1987. That was like the real, principal studies that have been going on into this, and they've been testing it in humans since early 2000s. And then, since it's so easy to change DNA now through molecular biology, we've actually been doing it with cancer medicines since the early 2010s. So if you were unlucky enough to have cancer and you wanted a personalized gene therapy, medicine for you, odds are that you're actually going to get it delivered with mRNA coated in lipid nanoparticles. And it's mRNA because that's the step right before proteins. The DNA to RNA step has a lot of regulatory things into it. You have to have a promoter on there, which, when does that promoter turn on? Why does it turn on? That kind of thing. It's just another barrier to the RNA world. And once you get into the RNA world, now we can go just one step more into proteins. So it's a lot easier. You don't have to go into the nucleus. You can just create proteins in the cytoplasm, and you don't have a problem with DNA integrating into the host cell's genome. Good. Those are all good aspects. So that's why we've always gone with mRNA. And basically, mRNA itself is something that's readily usable. So we're talking like, Lego bricks in a Lego factory. Like these are really important things. They're going to be constantly used, and basically proteins break them down really, really quickly and easily. And the idea is that we need some way to protect these things getting into the cell. So the original stuff in 1987 was liposomes coding the nucleotide, the mRNA. But now we actually just do lipid nanoparticles. So lipid nanoparticles aren't like a it's not like a an actual nanoparticle that I used for my PhD research. It's basically just phospholipids, kind of like those tails, if you remember the head and then the tail of the two like fatty chains that make up the cell membrane. We just use those, a bunch of those, coating the cell membrane. And the idea is that those actually protect the nucleotide from until it enters into the cell. Okay, so that's why we use that technology. That's what it is, and it's been used in mammals for over 20 years before the COVID vaccine. And the idea was let's use this technology that we have that's been vetted that we know that works really well, and let's use it because it's really easy to change the sequence. We're in a pandemic. There's going to be a lot of sequences that need to be changed constantly, and basically you can go from new sequence to new vaccine new vaccine batch within about 11 to 14 days with mRNA lipid nanoparticle technology. With live attenuated vaccines and inactivated ones, we're talking like a long period of time otherwise. So months and months. So it's a lot. It was a lot better to just go into this route. And basically that's why they chose that. When they went through the emergency use authorization protocol, they went through all of the same stages, but they just stacked them. So basically, they allowed the tails of one stage to overlap the other. Normally, they separate them out. So it's like, okay, do one stage. Okay, now we're going to wait a little period. We got to get the new trial going. All right, let's get the second stage going, and then that goes. But now, because it was a pandemic, they overlapped the tails. It was so efficacious, and there were such good results that they actually overlapped the stages. So they went through the same trials that everything else goes through, but it's just the time series was a lot quicker. And
Can I
go
just
ahead.
interject
Yeah, yeah.
real quick? Were all of the big companies? I know that we ended up with three that the government was
Mhm.
supporting. Were they all using the same basic methods? So what you're saying, does that apply to what all of them were doing, or did some of them get cute and do something that may have been different and unauthorized and more dangerous?
So basically, the tech that she won a Nobel Prize for this was Koriko's work with BioNTech, which is a German company. So she was a Yale researcher for decades, couldn't get her research funded. Finally, went to Germany. Was like, well, I'm going to create a technology, a company based off of this. They created it, spun off a company, and then basically Pfizer, Moderna had to license it and pay that company BioNTech in order to use that vaccine. So yeah, it was basically like 20 years of molecular biology to go from like the 1987 version to there, and then once that mRNA with lipid nanoparticle thing, that's what people see as the COVID vaccine. There were DNA based vaccines that were tried. That was the Johnson and Johnson's called the Johansson package that they they went through the trials and everything was found, but there was a higher proclivity for myocarditis rates and pericarditis rates, so they pulled it within like 10 days of going out. So it was like it was one of those things where it was higher than the incidences that we understand or saw during the time, and that's why they pulled those back. The mRNA vaccines, actually, this week we got some amazing news that the mRNA and lipid nanoparticle vaccines are actually having some cardioprotective benefits that we didn't see before in the study. So actually, there are some unexplained side effects of the mRNA lipid nanoparticle vaccines, but they're actually good. They help you if you have cancer. They actually help your body live longer with the cancer because it revs up your immune system so that your immune system fights the cancer. And then two, it actually makes your tumors, if you do have them, more sensitive to anti-tumor medications. And then three, they actually have some cardioprotective health. So your heart is actually in higher health if you're getting the COVID vaccine. So those
So,
three things are, it's pretty remarkably cool.
so just to be
Nice.
clear, one of the things that it would be easy to think is COVID hit in March. It was 2020. It was very clear,
Mhm.
and it was clear not too long after that that it was going to continue beyond 2020. I don't know exactly when that realization hit, and then it's like, okay, everyone gets started on making a vaccine. And what it sounds like you're saying is, no, we already had a huge head start
Yeah. Oh yeah.
on vaccines for this type of thing, and so we didn't just start from scratch and cram something together in 3 months.
Exactly, exactly. Yeah, so the from the papers and what we know, basically the outbreak happens in December 2019, and the Wannon seafood wet market. The SARS-CoV-2 genome is published February, I think it's like February 1st around then. And people recognize immediately that this has pandemic potential because it's a novel coronavirus, which meaning that we hadn't the spike protein, we hadn't seen it in our immune systems, and it had preliminary reports said that it had a higher ACE2 binding affinity. So basically, we have ACE2 cells everywhere, ACE2 handles and on a ton of our cells, and that's going to be able to latch on to those at a higher rate. So the scientific community, like in February, we're all like lighting flags, like this is not good. I remember my wife was pregnant at the time, and we had our kiddo's birthday in March, and I pulled the plug early before we know. And like I pulled the plug in February, like we're not going to have this because there's a pandemic going on. I don't know if it's actually here. My wife's pregnant. We're going to be cautious. Everyone's like, you're being like, what's going on? We bought tickets. This is not fair. Like, I'm sorry, guys. And they actually happened to be from Seattle, which was which is wild, which is one of the where the community spreads was happening. So, yeah, man, science has predictive qualities to it, and yeah, the scientific community was never wrong in the pandemic on all the aspects of it. It's really frustrating to have these conspiracy theorists kind of like posthumously say, "Oh no, we're actually right on everything," and it's actually the exact opposite. The scientific community was correct. It was just people like grifters and people that want to exploit um, people's lack of knowledge are kind of pointing out different parts of the pandemic. And in reality, the only thing that has predictive qualities in the future is science, and science was correct during the pandemic.
One of the things that deeply frustrates me is your country and the UK each had blonde bozos as their national leaders, and they completely cocked up all the warnings that were coming from the
Yeah,
scientific community. I listened to a lot of science podcasts, and I knew in December 2019 that there was something of concern going on. And
yeah,
my daughter was young and at home, and she and I used to talk about these things. And it was in the Christmas holiday, I was, in our regular chats about things scientific. I said, there's this problem in China. We need to be concerned about it. Worst case scenario is it's going to shut down the world. People are talking about this already. And
hmm
it was a concern because I was talking about this to a young teenager about something that was actually quite frightening.
yeah,
And then 2020 started rolling in, and it was like, guys, this is spreading. You need to start putting some policies into action. If you haven't listened already, if you don't know already, you need to do something. So I'm really frustrated that our respective blonde bozos cocked up what could have been a much better response. But that's politics. That's not science. But it frustrates me
Matt, do you
immensely.
remember around the time we were doing the Surviving Corona book?
Yeah.
One of the arguments that I would get on the board from one person in particular, who I just won't name, but I kept seeing it in society quite a bit, is people who are generally healthy are going to be fine. They might get the virus, but they'll be fine. And so the only people that it's going to hit are old people and immunocompromised people. And I've never gotten over that, frankly, because the attitude was just let the old people die. Why do we
Yeah.
have to wear a mask because old people are going to die? And I was wondering what the hell society have we moved into
Where that's
where
acceptable.
where
Yeah.
your discomfort with putting on a mask for a few months and doing 6 foot distancing at a grocery store is more important than the people you know who are gonna die. I I've never been able to get past that, and I've never been able to forgive people who reacted that way.
Hmm.
I'll be perfectly frank and honest, David. During that period, one of the thoughts that went through my head was we've got a world that's overpopulated with humans. Here is an opportunity for us to shed a lot of them. But to be honest, I don't actually believe that that was the right thing to do. It would have achieved a result, but the devastation that would have resulted from that would have probably been really atrocious. So, in case anybody's listening, don't cut this as a clip because I don't actually believe that was a good option. Okay. I think trying to save as many lives as possible was the right option.
It's
Yeah.
already clipped and playing. It's the
Go
views
on,
on it
TikTok
are
me, I dare you.
you're
I
you're
dare you.
gonna be infamous, my friend, completely infamous.
Go on. Uh, but this does touch on the again. So, from a scientific perspective, Greg, 'cause
Hmm.
again, this comes from the whole conspiracy thing.
Yeah.
Mandated vaccines. I'm sure you
Hmm.
saw this coming.
Yeah.
There is a level at which there is a percentage level at which the population needs to have protection in order for everybody to be protected. And why should we accept the declaration that it is our moral duty to take a vaccine rather than go and live in the countryside so that we can protect people we don't will never even meet? Why and why should science be invested in that argument?
There's a lot of different reasons. I mean, um, scientifically, we basically want to keep the amount of viral genomes low. So we want to keep the amount of them as low as possible because when you have a lot of them, then they can recombine inside of, when two strains will infect one person, they will do a genome swap shuffle
Mhm.
and then they'll kind of go from there as a new strain that has even more mutations than the past. So in order to stave that, we want to keep the amount of viral genomes to the point where when it does infect someone, it's the same exact one as the vaccines. So that's just kind of that's what herd immunity is, where you have
Mhm.
an efficiency and a virus of two that can infect one another, infect humans, right? And then that rate is married with a highly efficacious vaccine that can basically tamper down whatever ones that do spread to the point where it can't spread any further. And then there's a third leg to it too, where basically it's about the incubation period of the virus itself. So this is what people don't talk about, and it gets a little frustrating. Like there's never going to be a sterilizing vaccine for SARS-CoV-2. I mean, very, very, very unlikely. I mean, you can't speak in absolutes with science, but we're talking like 99%. Like, there's not going to be one. And we're like, why is that? Is it because there isn't really good vaccines? No, it's actually the opposite. The original during the alpha wave of SARS-CoV-2, the efficacy rate was like 95% for it was the greatest of all time of any vaccine for flu, because the flu vaccine's normally about 50 to 60% efficacy rate. So, and why is that? Why does that actually why does that matter? Well, it's because the incubation rate is the period of time in which the the virus stays in your system to exponentially grow and have that viral load increase inside your system. So something like measles, for example, takes about 10 days. Like it's like a latent growth phase that it has inside your system until it really kicks off. And basically it allows your body a time period in order to create the antibodies and in order to squelch it when it's in that lower viral load amount. So you have measles is a good example where it's the most contagious virus known to man. We have a really good vaccine, but because the incubation period is so long, 10 days, we've been able to have a highly efficient vaccine with a long incubation period, which allows it to basically be like functionally, eradicated from a region. It's not eradicated from the globe, right? Measles was never fully eradicated like smallpox was. Smallpox is the only virus that's ever been completely vanquished from the earth. There are inoculums in Georgia at the CDC center. Whether or not we actually kill those virus inoculums is kind of like a point of scientific debate, but that smallpox does exist on earth in freezers in Georgia. um, but but yeah, I think the other aspect that's the scientific argument for it. I mean, vaccines are the largest economic driver I think that we could even spend on in terms of a government. So it's like 11-to-1 economic driver. Every dollar you save, every dollar that you spend in vaccines, you actually get like $11 of economic output because people are going to work, they're going to Coachella, they're going to festivals, they're going to grocery stores, they're going to Costco's. You're not going to go to a crowded workspace or a crowded grocery store if there's a good chance that the 24 pathogens that we vaccinate for are alive and well inside that market. I mean, is the bread really worth it for that? Are you really going to go to that football match if there's a really good chance that you come home with measles and you kill your grandma?
Not a
Like probably
chance.
not. Really you're going to stay home. So vaccines give us liberty. They give us freedom, right? They actually allow people to exist in large, unnaturally large, societal gatherings. And as humans, we're social animals. Like, right, we want to be next to one another. So it kind of like makes sense that we push for that. In in terms of mandates, I think that this gets lost a little bit. I mean, even we should say herd immunity did exist. When polio, it's just that the fear of polio was greater than this fear of like individual mandates stuff that we talk about now. I mean, the fear of your child being paralyzed or dying from polio was so great that people lined up out, for blocks in order to get the vaccine. This wasn't. This was real. This was a real fear that people had, and it's just we live in a world now where vaccines are so good and they're so we've regulated these dangerous pathogens to the point where we don't have to worry about them anymore. And then now they're kind of vaccines are a victim of their own success in a way where people think like, well, what are the vaccines even good for? And it's like, well, you don't even know. You don't even know what they're. You don't even know anyone with polio anymore. That's how good they are.
So, just a real quick one. Matt, look, he's a great host, but he's not than me at stealing the mic. So he would lose on Jeopardy because he's too slow hitting the button. It's not like he
That's
doesn't know
true.
the answer.
That's true.
I would hit the button every time, and I just, miss the
Then you'd wing
questions.
it and somehow
Yeah, I
you'd
wouldn't know the
guess
answers.
something that was vaguely right. I mean,
So, but that said,
I
there
hate
was
you for it, but you manage it.
measles, things like measles, chicken pox. I had chicken pox when I was little. Schools have been dealing with those sorts of things for a long time, and the vaccines are mandatory. In fact, when I was little, you could get them in class or in the nurse's station.
Mhm.
They were mandatory. There came a point where you couldn't even enroll your kid in school without the vaccine. That still may be true for some vaccines, but this is one of the ways that we kept some of that stuff under control, and Christians were fine with it.
Yeah.
We never heard of an anti-vaxxer during that time because there was nothing wrong with it and they wanted to live too. So something different happened with COVID, where all of a sudden it became the right of Americans and we'll just say conspiracy theorists
Yes, because
slash
we told them not to go to church.
religionists.
That was why we trod on hallowed ground there, David. That was
So
the problem.
there definitely might be some of that, but they were anti before then. And I'm just wondering, Greg, if there was anything in the science about the vaccine, anything in that moment that made people resist the vaccines in a way that they just never did in the past.
I mean, I think there are always the people that I debated during that time back in 2020. Like, I'm not anti-vaccine. I'm just anti this vaccine. Like,
Mm-hmm.
that constantly was a big thing that people said. And you can cherry pick things that are different, right? The emergency use authorization, right? Well, guess what? As soon as the FDA approval was full, now all of a sudden that's not long enough. No, we need 20 years of data. No, what's 20? Well, we've had 5 years of data. With the people said they needed that everyone's going to have mass death within 6 months, 1 year, 2 years, 5 years. None of that mass death has happened. It's always one thing, another thing, and in a way, I mean, it's called like concern trolling now, where they're feigning oh, I care so much about vaccines. Actually, I'm not anti. This is RFK saying I'm not anti-vaccine. I'm pro-good vaccine. Your vaccine just is never good enough to my threshold of standards, and I mean, we just have to call BS on that, right? We have to like say like this is wrong. You're endangering people's lives. There's always going to be some unknown that exists in the world. But what's really is known are viruses are real. Viruses cause disease, and hundreds of millions of people lost their life in the 1900s with because of this stuff. So stop leading us down a path where you're going to have 4 million kids die every year and 1 million older folks that are going to die, which is the stats. 5 million people of lose are saved every year because of vaccines. So it's not negligible, and we're seeing the rollback in a lot of stuff now. We have measles outbreaks in the United States right now. We had it in Canada for last year, which was the biggest that they'd ever seen. And it all comes down to kind of this anti-science belief now. And I think the thing that has changed, I do think that there is, some Russian disinformation in there. I
Of
think
course
that
there is.
is,
Yeah.
yeah, I think that's actually not talked about enough. Like, genuinely, I think you look at the Mueller report, and you look at the Senate, the Republican Senate report during those times, and how disinformation. There's just 1,000 pages, three separate reports released by the Republicans about the 2016 election, talking about how they seed these disinformation campaigns into it. And I think the stat is like 60% of anti-vax content comes from 12 creators or something
Mm.
like that. It's just astronomically effective at being spread on the internet, and it's because, like we were talking about before, it's just easier to spread conspiracies than it is genetics and virology basically. But I think like now is the time to really engage with this, and science. I feel like during the pandemic we didn't have a lot of vaccine advocates. And that was my frustration about it. We had like Fauci going up there as kind of like a punching bag. But like the scientific community itself wasn't going up there and saying, "Hey, this is completely wrong what you guys are doing." That we've been here, we've been working at this. By being anti-vaccine, you're against American ingenuity. Make it patriotic. Make it. This is American ingenuity that did this. We created this technology, and the Germans did technically, but we did before that, or we did in the
Mm.
United States before that. We helped seed this technology, but I think that's how we have to phrase it going forward in order to actually like battle this stuff.
I don't want to get stuck on vaccines because this will just become a huge va vaccine episode, although it is very important. So, people on David's listeners, if you've got questions about vaccines, you've got concerns, you're wrong, but put them down in the comments, and David and I will collate them. And when I talk to Greg, because Greg is definitely going to get an invite to Still Unbelievable, we can address some of those. So I'd
Love it.
like to move a little bit to bacteria and that kind of thing. And my segue to that is we have a problem with antibiotics and antibiotic resistance and being very careful. So the way we treat bacteria and antibiotics is different to the way we treat viruses and vaccines. Why is there not an equivalent of antibiotic resistance in viruses for vaccines, or is there? And why is that a less of a concern in vaccines?
That's a really good question. I think basically viruses aren't considered living, and because they can't live by themselves, and bacteria can. And
Okay.
bacteria are capable of living outside and separately than the host, which allows it capabilities to live and we can't really live outside of bacteria, basically, bacteria and yeast, microbes in general, like I said before, like they're half of our cell count. If you took every single cell in your body and counted human microbe, it's about 50-50. So we desperately actually need microbes in our life in order to help our immune system function, to help the gut brain connection, how your gut microbiome actually connects to your brain and contributes to things like brain fog and things like that. That's actually been a study and research right now. So a lot of times, and basically what happens is that bacteria have ways of sharing DNA that's really completely different than anything that we understand as humans. Because as humans, we only understand vertical transmission of DNA, or heredity through mom and dad and grandparents to me, right? Versus like imagine being able to have like your friends, you're at the beach and they have like this ability to tan in real time like my wife does. Like she could tan in like 15 minutes on the beach. Like imagine her just giving like here's that DNA for your skin. I put that tanning ability on my skin and boom, I can tan as greatly as she can instantly. Well, it's like horizontal genes transfer that exists as bacteria. And why that means something for bacteria specifically is because they can basically be being introduced to, it's called a pathogenicity island. So a piece of DNA that would turn just a regular old bacteria into something that's deadly can just be that little piece of DNA that can actually be inserted now into that bacteria, and now that can take over your system, and now that can be like a pathogen that you wouldn't have before. So that's kind of like uniquely why we have a war with bad bacteria, because we have good bacteria on us
Mm.
and we need it. I do think your point about antibiotic resistance is so true. It's very hard to find antibiotics. It's one of the reasons why I think that microbiology is such a cool field. I mean, I'm a microbiology PhD. I'm very, very biased, but I truly feel like it is the final frontier in terms of humans and research on Earth and biology, because there's so many microbes that we have never cultured or never sequenced, and those have medicines like antibiotics in them. They have fuels for biofuels that could run our cars. They have materials that could be, for our foods, that could be for our clothes. Tons of different ways that microbes can contribute and better our lives. So in order to fight bacteria, we have to kind of go to other microbes like yeast and those type of things, because those have antibiotics in them. Those create the stuff in order to keep them away. That's what penicillin is based off of. So we have you know we basically have a problem in that bacteria can evolve, and as they evolve, they can create resistances to drugs that allow us not to have a sterile environment. That could be, a problem for when you're going through any type of procedure, you've been opened up or that kind of thing. But I do think in the future, I do think going forward, we have a huge resource in one, finding new antibiotics that didn't exist, but then also looking at probiotics. So think about it this way. Instead of you taking antibiotics after a major surgery in order to clear out like the infecting microbes, what if you had a gut microbiome pill that you took in order to help sway or jut your microbiome to a specific region that would help you recover faster, so you didn't have to kill your gut microbiome or your diversity there? What if we use the gut for specific healing properties in terms of anti-inflammatory or types of ways that the immune system can be bolstered through your gut microbiome? So I think that's like honestly the direction in the future is going to be actually utilizing the gut microbiome more, because we're just finding it actually impacts humans more and more in more aspects of our life and our health.
Thank you. I'm going to take a very quick tangent on this, and because an episode that David and I did a long time ago has just jumped into my mind, so I can't get it out of my head. So please forgive the frivolous
That's fine.
sideways question. The teletransporter in Star Trek,
Okay.
does that have to do the human body and the bacteria in order to properly transport you?
It would have to. It would have to.
So we've just destroyed the whole concept of the teletransport transporter, then, haven't we?
Yeah, maybe. Maybe. It
Yeah,
would have to. I
because
mean, otherwise,
they block out don't they block out the bacteria and
Yeah,
viruses and other
it blocks out
everything?
pathogens, doesn't
Yeah,
it?
it
So
just
you don't bring anything in. So, boom.
good
You
point.
just land at the other place as a meat sack with no bacteria. I mean, it's great for weight loss, but
Yeah, I mean, you're basically susceptible to a whole host of different things now to in order to you get taken out, basically. So it's a huge portion. You'd be more likely viruses and pathogens like landing on yourself. That your good bacteria battle those when they land on you. Your gut has a ton of antibodies and stuff that they produce from it. So it would be bad. I mean, we do produce mammals in sterile environments. So mice, for example, in a research facility, they're going to be born without being seen any bacteria, but those aren't healthy mice for like the world. You know what I mean? Those are just for research purposes.
okay. So there you go. There was a fun interlude. Enjoy that in the comments because Star Trek is clearly the inferior space-based sci-fi series.
In the just real quick in the invite I sent. If we're going by that alone, we've got about 10 more minutes. Greg, realistically, how much time do you have?
I'm good for like another 40. We can like keep chatting. We're good.
There
Okay.
we go.
Don't
So
don't say that to
don't do
us.
that. David and I have
Don't
done 3 hours
don't do
before,
that.
Greg. Don't give
You
him a
always
piece
want
of
to be
string.
specific. Do not give me a blank check, sir.
All good.
All right,
Um,
Maga.
so sticking with bacteria, I mean, bacteria is obviously clearly of enormous importance, as I'm aware of that. I'm glad you said take a pill there and not a fecal milkshake, because the idea of a milkshake, I don't know, it just sets off mental images to me which are unpleasant. I'd much rather have a tablet. Thank you very much.
True.
Um, so in order for evolution to be true, our bodies and the bacteria that we co-depend on, because presumably that bacteria depends on us, our host body as well, there must have been some co-evolution going on there, or some form. How does that strengthen the argument for evolution? Because old creationist me, is thinking, how could this possibly happen in tandem? How could this possibly work? So
Hmm.
sell that to me, explain that to me.
That's a really interesting question. I think that it's best actually seen, I believe it's in dogs. So you can actually see the evolution of dog domestication within their own genes in terms of which genes is turned on or off in the presence because of the food and the wheat that we were eating. There was that I can't think of the protein or the gene at some point right now, but there was some way of like watching that and basically seeing how once that gene got turned on, then there was like a molecular clock mechanism that we were talking about before, but that basically turned on. You can like see that over time. But it's escaping me right now. Um, yeah, I mean, viruses. I mean, viruses and so bacteria in our gut are going to be different to our locality and like what we eat, and we do see the differences between like urban and rural diets and in the same location. And then there's also going to be a lot of like different things within terms of like how you come out, like C-section versus vaginal births are going to have different types of things, exposures. But to me, like what I don't understand, like how something that's so integral to how we exist in the world and germs and stuff, like how is that just not in the Bible? Like how is there not a parable of like a hidden microbial world that we don't know about? Like why isn't there like a parable about a winding staircase, a double helix winding staircase or something, or ACTs and Gs, which is the codes of DNA. Like why not why is there not like a story of two sisters that just or four sisters that only pair with each other, and you know what I mean? There could be so many different ways for us to understand, and obviously if someone's a creationist, then this is the language, this is the actual language that God presumably made everything through. It's what, I share 50% of my DNA with a banana. Like how is that connection not shown and seen inside of the Bible? Like why? How is that? And it's because of it's basically the the warehouse back of the house kind of processes, the molecular processes that took billions of years to evolve as prokaryotes. Basically, we still have those. How to make this and maintain the cell, DNA, RNA, proteins, all that kind of stuff is conserved. But like, why is there no talk about that in the Bible? So
So let,
it's just completely absent.
let me just because you said theology things, so that's me. um, can let's help the Christian out a little bit. I mean, I can't do it, but maybe you could. Part of what is in the Bible is extremely long-lived humans. Let's throw out the 1,000-year lifespan. Is there any evidence or any kind of way you can think of scientifically, based on what we know about the Earth now, that sometime 100,000 years ago, say 150,000 years ago, we could have lived significantly longer than we do because of fewer viruses or fewer strains of bacteria or some difference in the environment? Is it plausible that if such evidence maybe could be found, so that instead of living 70 years, we lived 150 years?
I mean, I'm not. There are organisms that live that long. Not humans. I mean, bristlecone pines are the longest living organisms on Earth, and they're about 15,000 years old. So there are organisms that do that. Their just life cycles are completely different than humans. I don't think that there hasn't been any evidence of that, and I think that you have it happen. There's so many humans now that even if it was one in a million, that someone's living until 900, I mean, there would be 1,000 people on Earth right now that would be living for 1,000 years. So it just the fact that it's not happening all the time, I think it's kind of a testament of there's just it's just not going to be possible. I mean, we have the best medicine that's ever existed in the history of the world today. So, like, in order to keep people alive the longest, we have those technologies now, and there just doesn't seem to be any reason or to completely stop that aging process that happens naturally in all living cells.
Thank you. Back to you, Matt. You can answer a smart question now.
Um, I'm going to springboard off what you asked, actually, David, because it's given me an idea. So, do we see evidence of evolution in the bacterial genome? If we go and dig up an ice core that's 800,000 years old, is there a chance that there's bacteria that's in stasis in that ice? Can we examine it? Can we see its DNA? Can we then say that's an old bacteria or something we've got around today? Can we do some kind of genetic analysis to demonstrate or investigate evolutionary progress on that? And to go into science fiction world again, could that bacteria then infect us with something really novel and create something that's really horrible?
Yeah, that's a really good question. So stromatofores are the oldest fossilized remnants that we have. So that's about gosh, I think it's like 3.8 billion years old, cyanobacteria. So cyanobacteria are basically the chloroplasts of plants. So, but the cyanobacteria were once a free living organism. So basically, they're solar panels, like free, like self-replicating solar panels that just existed as single-celled before, like a eukaryotic cell said, "Hey, you're kind of cool," and then put it inside of its body, and then it became a plant. That's what an algae is for the first time. So that was the evolutionary thing of that.
Sorry,
Yeah.
just quick interruption. Isn't algae a dirty word now?
Oh yeah, I know. It's so funny, dude, because I've been doing algae science for 17 years, and it's like algae is like in the zeitgeist now. I'm like, I don't know how
Yeah,
to. That's actually what this is in the background. This is my PhD like figures and stuff with actually like
awesome.
delivering the DNA to Chlamydomonas ronhardi, which is the green algae that we use as a model organism. But
So it's your
um,
fault.
yeah, exactly. Well, as I teased, this is true, guys. This is 100% true. Algae is not real. It's never been isolated. It doesn't exist, and it leaked from the lab. There's actually if it was real and it's not, algae leaked from a nearby algae lab in Washington D.C. and Trump leaked it himself, I guess.
He was stuck to his car tires as he drove through.
Yeah, exactly. But what you're talking about is a really interesting question in terms of pathogens frozen in permafrost that is a concern legitimately. So basically, as the world's climate changes, basically pathogens now have a broader range than previously existed. So, for example, viruses and ticks and stuff like that in the United States can basically go higher now at higher altitudes than previously, and it's because of the summers are warmer longer and the winters aren't as harsh for as long, so they don't have that dying off period that it used to have, and that's kind of happening now at the poles now where you have it's called the permafrost where these are ice that have it's kind of cool. One of the reasons why, well, the reason why ice floats is basically because the it creates like a hexagon, like a 3D hexagon, and then at the center is a pocket of air. So what that causes is some really cool things like the entire world is shaped how it is, because of ice floating, which is the fact that a solid floats on its liquid counterpart is pretty remarkable if you think about it.
Mm.
But that pocket of air tells us a lot in terms of climate, right? That's how we understand the CO2 ppms hundreds of thousands of years ago. We can actually sample that CO2 level that's inside of that ice core sample. And then also within that would be any pathogen. So any type of virus or pathogen that could be inside that sample that then could leak out and could presumably infect humans, some percentage of them, but maybe we haven't seen that virus before, that type of virus. We've never worked with it. We've never cultured it. And it has an ability to somehow bind really specifically to a cell in our body that we, didn't, that's really abundant. All these things, like imagine SARS-CoV-2 was just a unique spike protein, which is what made it novel. But we had already worked with coronaviruses before. Coronaviruses are known to humans. We had cultured them. We'd worked with them. We had a vaccine that was nearly done, and then we could just copy and paste that specific bit in, and now we have that. Like, what if it's an all new, different type of virus type that we have to figure out? Like, what is this? And so that is a legitimate fear for as permafrost melts, what could come from the depths. We're unknown on what could be underneath there.
Uh, Thank you. That kind of reflects what I thought I understood about what was going on there. So thank you. Should we also be concerned about those kind of pathogens being delivered on meteorites?
That's a really interesting question. Um, Bennu did show that there were the initial building blocks to RNA on an asteroid that was just flying through our solar system, which is just wild to think about.
Mm.
I'd honestly the thought of I think it's like the Gaia Earth hypothesis, where basically our Earth is seeded with the precursor
Mm.
to life, and then it evolves there here. I'd never really put that much validity into, and then Banu came about, and I was like, wow, that's a very likely possibility now, that basically the Earth is seeded with the precursors to RNA. There's enough precursors that come. There's like like a shower or something, and now these things happen. It's in a hot uh, environment, a lot of energy. These precursors, now RNA folds
Mm.
together and starts folding together. Um, and now then that's the RNA world to DNA to life kind of abiogenesis. That's our current hypothesis for how we understand where life came from Earth.
Uh, Thank you. Again, it's just an interesting question. I'd
Mhm.
like to touch, because I know we're in dying seconds here, but I would like to touch on irreducible complexity. Why can't I say
Yeah.
that phrase? Because again, for the context of David's podcast and the conversations in his forums, I think it's a very valid question
Yeah.
to ask. So one of the big things in apologetics is irreducible complexity, and one of the bacterial flagellum is one of the flags for that. You also got other bacterias which appear to move under their own locomotion. You've got weird things that look like cogs interlocking. So there seem to be really strange mechanisms that exist within bacterium, which look oddly familiar to things that humans have actually created themselves. Why should we still trust that these are evolutionarily created? And what kind of seriousness can we take to a deity creator of these kinds of things? And is irreducible complexity an accurate description of these things?
Yeah. So basically everything that exists now in biology is as evolved as everything else. So as
Mhm.
evolved as I am to think with my frontal cortex and to postulate philosophy and science and all that kind of stuff, the bacteria is as evolved as that at moving, at uh, taxiing through the world and finding gradients and all that kind of stuff. So there, we have to think about it in that terms
I
because
think that's a great reminder to put that in context like that. Thank
yeah,
you.
yeah, because it's like that thing is highly evolved and specific to do that portion, but then there are different paths of basically, when that thing happened, it's trying out like different different bits and parts together. So it's not going to be just like an assembled car, right? That we
Mm.
kind of like think about, but it's more of like, let's see like the wheel or something. You're bringing parts together. It's kind of like a patchwork of different things, and they're all being tried out. And then through evolution, you go through and have a step forward in a direction that might not be for a car. Maybe it's
Mm.
something else like, you create a mug with something that's a circle first before you make a tire. It's kind of there's different paths in evolution that aren't straightforward, and it doesn't give you the landing point at the end every single time. So, but we know and we can track through like the eye is a good example and something that we see in a lot of the irreducible complexity arguments that you look at our eye and it's like, oh, there's the thing is, oh my gosh, it's, what would you do with half of your eye gone? That wouldn't work. It's like, well, that's not what we're claiming through evolution, right? It's like a single chromatophore, a single ability for a single piece of a protein to catch a photon is going to change that. So that's going to latch onto something else specifically now, and then that's going to create something else. I mean, we actually have that through oncogenetics, I think it's called optogenetics. The idea is that we can turn on and off genes now through just the presence of light. So you could shine a red light on something, one
Wow.
set of genes turns on, and then you turn on a green light, and then another set of genes turns on within bacteria. So, we have like really specific and abilities to capture light like at the protein level, like that the single like the protein level. So it's not like you needed an entire eye in order to capture light, right? And through evolution, we can see and the ability to detect light is so advantageous that you have tons of different parts on the tree of life all evolving these things at the same time. So it'll be like an eye spot versus an actual like cupped eye that we are seeing. And through the animal kingdom you can see different types of eyes that are evolved for different reasons. And just basically these different things, you see it with flight too. Flight's a good example where like snakes, for example, will glide on use you use their scales to glide, but those genes and that pathway for that snake to glide um, on the air is not the same as the glider rodents and mammals that can do the same thing. They can kind of like glide in from canopy to canopy. So it's not like they're related, but they've evolved something that's a very similar function. And that's basically what we see with through the bacterial evolution. We see that there's tons of examples all throughout the evolutionary like history of the world. But basically really important things are tried and tried a lot of different ways to see if there's another way of pushing forward, another thing to be added on here. So, presumably with the flagellum motor, right? Maybe there was a variant that turned this into a V12 instead of a V6. You know what I mean? That said, hey, what if we revved this thing up and we had like more of an ability? Would it go faster? And then that bacteria, that gene would just be copied or to have like more of that portion or something to tried. And then basically that V12 versus the V6, that would be tried through evolution, and that those bacteria populations would, if it was more advantageous to have the V12, they could really, they could swim that much faster. And they would use more energy, right, in order to do that. But maybe it gave them a fitness advantage. But presumably they haven't, or maybe they haven't. I just don't know about it. But that we can kind of like see that. And yeah, evolution is so cool. The story of evolution is absolutely fascinating. What we can see through genetics and through the evolutionary history of the world.
Can I follow up on the irreducible complexity? Are you familiar with Michael Behe? Because
Sounds familiar.
you went to the eye, and that's one of his pet peeves. He's a Christian. I don't really know what he is to the scientists, but we'll say a biologist of some kind. For those listening in the
Is
audience,
he the one who wrote the book Return of the God Hypothesis or something like that? Or am
Behe,
I
I don't
mistaking
know.
him for someone else?
I think you might be mistaken. He's I can't think of his great work now, but for those who know of Behe, I believe that Dale, our Christian friend and podcaster, has interviewed him. I don't have a link to that, but if I can find it, I'll put it in the show notes. So if you want to know a little bit more about this topic, Michael Behe is
Oh, yeah, Stephen Meyer, I think,
it,
wrote the book I was thinking of.
and so that just a PSA. My question is concerning the eye in particular, because I know a little bit about the evolution of it, Christians would say it has to have been created exactly the way it is without previous steps, because what good is a half an eye? This has been debunked many, many times, and half an eye at the time there would have been something like half an eye would have been very advantageous to the creatures at that time. Fish eyes, very advantageous. I'm glad I don't have them. There may be creatures who would look at us and say they only have half an eye, like maybe an eagle. We have the expression eagle-eyed. No one ever says human-eyed. And so is it possible that evolution down the road, our progenitors would say, man, what good was half an eye? They couldn't even see infrared. They needed machines to see the X-ray spectrum and see through people. They need
Yeah.
what good was the eye before that? And so I guess that's just that is what comes to mind. I guess my question is there anything in the microbiology world that would indicate an endpoint to evolution in some state? Because what the Christian argument basically is our eye has reached its endpoint. It was supposed to be this way. So prior to it being this way, it would have been no good. But getting here is the goal. This is the end point, and there's no reason to believe that it would change further to be something radically different than it is now. Is there anything in evolution, especially at the biological or microbiology level, that would justify that idea that there is an end point?
Yeah, I mean, if the eye is the example, then I guess God is a mantis shrimp, because like mantis shrimp have like 16 different types of cones and we only have three. Mantis shrimp can
Wow.
see in ultraviolet and infrared light, so they have way better eyesight than we
Yeah, but can
do.
they see through clothes? I
Yeah,
mean,
exactly. So yeah, it's stuff but it's stuff like that where I'm like, man, we don't even humans are very rarely the best biologically at any single thing. There are lots of different examples biologically of that being the case. And I mean, the eyes aren't necessarily the endpoint, right, for a lot of organisms. So, like for example, there are like cave newts and stuff that have basically amphibians that have obviously evolved outside of caves, but now they live inside of them because that's where bats and other, insects live. So they want to live in there. And in pitch black caves, they have the genes for eyes, but they've accumulated mutations to the point where the eyes don't form anymore. Because if you're in a black cave, an eye just is worthless for eyesight, but it is a negative in the fact that your eye can get infected and you could lose your life for it. So the newts that had the deleterious mutations in those genes, well, they outbred the ones that were dying of infections inside their eye. So, evolutionarily advantageous for those newts was for mutations to turn things off. That's also a thing. And that also happens, by the way, with primates and vitamin C. So mammals, vitamin C is essential in our immune system. So mammals, like my dog, can make their own vitamin C, but humans can't. We have basically primates, and long past evolutionarily, we're eating so much citrus that we were having so much vitamin C from our food that the human or the primates that turned off their vitamin C gene, well, they outbred the other primates, right? So there are no primates now that have vitamin C turned on, and those exact same mutations in the pseudogene, by the way, are shared amongst primates. So like it's a really good example of like evolutionary history tying a group of organisms together for a similar function. That I mean, why would a god or a creator put deceptive genes in the specific order with the specific null mutations to create specific premature stop codons in only primates? Like it doesn't. It's really really odd. And by the way, and evolutionarily speaking too, really interesting. Guinea pigs have the exact same thing where they actually don't produce vitamin C as well. But their pseudogene, in order to turn off their vitamin C, actually has a different set of mutations that turn those off. So even amongst vitamin C lacking organisms, we don't even share the same like mutations. So it's which obviously is true, right? Through evolutionarily speaking, it's from DNA errors and not just like someone flipping the switch. So there's lots of examples of that.
I'm going to go ahead and give Matt the last question here and consider this my...
I've got several last questions, David.
Okay.
They're stacking up. They're all fun, but they're stacking up.
I'm gonna go ahead and say categorically, you've been the smartest man to ever appear on the show, and Matt has been on the show. And so...
Yes. Thank you, David. Love you as always.
So I am going to... hey, Matt, are you recording by chance? Or are you?
Not,
are
no,
you?
I'm
you
trusting you to record.
Yeah, I am recording. I was just wondering if you had access to the off button.
No,
you don't. Okay.
Just checking.
So if I got up and had to go out, you wouldn't be able to.
No, I've got a record button. I've got my own record button, but I didn't hit it because I trusted you.
Yeah. Well, that first of all, dumb. But I'm on it. But I just did want to say thanks for this. I'm going to be going through this for weeks. This and some science books to work out all of this. But this is a level of science geekery that Christianity pretty much never sees. They just never see this, and by the time you get to this level of microbiology, chemistry, that sort of thing, you don't hear a lot of the Christian stuff. This kind of wipes all of that off the table, and it makes religious pronouncements sound very anachronistic. And so I do appreciate this. And with that, I'm going to give it over. I'm going to actually mute my mic and keep it muted. I am going to give it over to Matt, and you can ask whatever questions Greg will let you ask, and you can even close out the show.
Careful, that's dangerous.
Do you know how I close out my shows?
You don't have a closeout. You just say
skepticsandseekers.squarespace.com.
Oh yeah, that.
Log in your Discuss account, discuss away. Send me an email at skepticsandseekers@gmail.com. This part you should remember. Until next time, I'll see you in the comments, and in the meantime, I'm out. So I am, in fact, out. But what we have for the last bit of this are the eggheads. So let's.
Okay. Thank you, David.
This is the end of the common man's part of the show.
But I loved your point, Greg, about the DNA that you were just making. I've made that point myself multiple
Mhm.
times, and the pushback that I've had most often to that point is God could just create that kind of template in multiple organisms because he's efficiently creating from the same building blocks. Does that convince you to take the God idea seriously, and why not?
No, I mean, if they're gonna say an active, deceitful, creator, then I mean that's okay. I mean that if that's what they're gonna have to be, and there there are other examples that just don't really make sense. Like, it's like okay, well then he didn't create everything in the first 7 days or something, or we're still in one of the days and he hasn't rested or something, or because there's bacteria now that have the ability to digest nylon. That nylon has didn't exist until 100 years ago. So how did nylonase evolve? Well, like in those types of bacteria, like are they just creating new strains of bacteria? Like how is that? And this is where they always fall to. They have to accept microevolution. There has to
Yeah,
be like some uh, you know, iteration of that. But largely, um, the endogenous retroviruses being at random locations, and then on top of that, the molecular clocks randomly, having those DNA errors, is once you understand that process, I mean, you know, it's pretty obviously like something that couldn't have happened. But yeah, if if God wanted to do that and his template was really trying to deceive people as much as possible, and he put in our DNA 2% that made coding regions for proteins, and 8%, so 4 times the amount of fossilized viral DNA remnants in our cells than protein coding genes. If that's the type of God he is, then okay.
yeah,
So
not the most efficient, really, is
yeah,
it?
exactly. So then he's not good at this, right? We're saying that he isn't, right? And that's also something that is, young Earth creationists have to. He has to be a good at this, right? As an engineer, he has to be a pretty good God in order to be omnipresent and omnipotent. But in reality, 99.9% of species that have ever existed have gone extinct.
Mm,
So, how good is he really? So then that's
mm,
when you get them to say that. That's when they say, "Oh, well, we don't know that those have ever existed or something." And you're like,
yeah.
"Okay, bro." So now you're like, it's not even just a now we're in the Looney Tunes like style of like dinosaurs are fake, fossils are fake, ancient viral DNA doesn't exist. The ice core samples, you can't just count the layers of years. So at some point it's like there really is no evidence that can sway someone. And I would actually ask to those people in these scenarios, when I get into these debates, it's like, well, what evidence would sway you, and what evidence would you accept for evolution? There's usually an example of that, but like for me, I could tell you like the evidence that I would need in order to like believe in God. It'd be very tough, but like I could give you like some criteria for sure.
Mm,
But usually when Christian apologetics, comes in, it's like it's never going to be enough.
mm. For me personally, out of interest, for me, the threshold that I had to cross for me was it was an understanding threshold because the creationist mentality towards evolution is usually something along the lines of one animal gives birth to an animal that's not itself. And it's like, well,
Yeah,
how does that happen? And so for me, the understanding that that wasn't actually what evolution says and that evolution
yeah,
works over time on the group. And it was when
exactly.
that penny dropped, and it took months. It took months of reading, it took months of thinking, took months of objections, then going back to answer my objections, and it took active desire to understand evolution better. Then suddenly the penny dropped, went, oh, that's how it works. I think when I broke that barrier and got that understanding of how evolution works, then so much more flowed out of that. So I guess out of interest, on a question to you in the conversations you've had, have you seen that transition with anybody that gives you hope, or that you're actually having some impact on educating people who are skeptical?
I've had honestly the most success with converting people that are anti-vaccine to
Okay,
taking vaccines.
nice.
I've never had anyone that's like I deconstructed their religion or something. I had people say that they went back to school because of like
Right.
what I said, what I've talked about,
That's
like
good.
my own because I went from like community college all the way to a PhD, which took, you know, like 15 years, and
Mm.
so it is a long path, but a path that I was like definitively my own. And in talking about that, I think is anyone on the internet, I think it's good to just be as open and honest and transparent as possible. And you know, you can it just allows people to relate to your story a little bit, and so that's always like heartfelt for me. But yeah, I've had several people actually. Some of my biggest supporters are actually Republicans, which is interesting because that's not like my politics, but they like the fact that you know, I will say it how it is. I will, you know, speak truth to power kind of thing.
Mm.
And they won't agree with me politically about things, but like how I walk through things and how I will say things, they respect it. And so I've actually had some of them, um, like, well, I had one that basically he figured out that he was wrong about vaccines, and he got himself and his kids like all up to date for vaccines, you know, because of that. So that's been really cool. I've had basically we have vaccine parties, so we celebrate
Awesome.
people that get vaccinated. So like if
Nice.
anyone comes in and they say they've gotten a vaccine for them or anyone in their direct family, we I put the marquee up, you know, and we celebrate basically I think we're up to 1,400 now. 1,400
Very
vaccines
cool.
just in my community just in the last year alone. So, you know, people say like that one of the favorite things about getting a vaccine is like coming and having a vaccine party in my stream. So, it's like,
Mm.
you know, I
Awesome.
think there are those like small little like community reinforcement wins, and then there are like the breakthroughs that people have. And those are honestly, I've had like more than a dozen now of people
Excellent.
like that. So it's pretty
I
cool.
can definitely believe that, because it took months for me to go from questioning evolution but prepared to investigate it to
Hmm.
fully accepting it. So you can't shortcut those months of reading and
Exactly.
thinking it into a single conversation. So
Yeah.
that tracks with my own experience. But hopefully you're planting seeds in people to give them
Exactly.
the same impetus that was given to me in an unhelpful conversation which I had, which left me feeling quite raw in my non-understanding.
Yeah, it
So
can be very like upfront, like in like you're basically asking someone to challenge their entire worldview, you know,
yes,
and it's never going to happen in one conversation. You're never going
no,
to be able to have someone just be like, "Wow, I totally believe what you believe." What you're, and I love how you said that too, and I use the same metaphor as like I'm planting a seed that they have to water. Like I
yeah.
can't once I've had those questions and stuff given to them, they can do with it what they want.
Mhm.
But usually, if I'm actually trying to like talk to someone and trying to really, and it's like a really good conversation, I'm actually asking questions most of the time. Like
Yeah,
me
cool.
being in professorial mode, me kind of like professing, you know, this is what academia is, this is what we believe, those are cool stories. But at the end of the day, asking someone or asking one of your friends, like, why, no, but like, why do you believe that this space is a projection? Like, why do you actually believe that that space is fake? It's like, well, because that's what all the best scientists believe. It's like, well, why do you believe that? Like, what scientists do you believe? Well, it's like what the scientists that believe. Where did you get that? Oh, it's from. Usually, it's from your social media. Usually, it's from like a, you know, a podcast that someone said something. Okay, have you actually read that paper yourself? Why do you believe that though? Oh, I no, I haven't read it myself. So, you know, that's how you can kind of like deconstruct, like, why do you, and usually it comes up to like, why do you believe that people are telling you the truth on the internet? Like
Yeah,
maybe that they have something to gain out of lying to you. And that's kind of like usually how the deconstruction happens.
yeah, good. Thank you for that. Do you, one of the problems that I think exists in science communication is the limitations of the language that we use.
Yeah.
In the last 2 hours itself, you've used the word like or try. Sorry, you've used the word try multiple times when describing bacteria using features, etc. And try is a bit of a loaded word.
Yeah.
It has connotations of consciousness behind it. And one of the other words that's often used in science is purpose. This gene's purpose is to do this. Again, it has connotations of conscious around that. Do we need to be more careful about the words that we use in science communication, or do we need to expect the other people just to get on board with what we mean by these words? Do we need new words in English to express what we actually mean when expressing these? Because English is very limited in being able to express what we really mean when describing scientific things.
Yeah, this is you're talking about something that I've the most pushback I've ever gotten on in like science communication was ever trying to change the word hypothesis and using something that is like a little bit more concrete and the more colloquial understanding of the word theory and hypothesis. Like hypothesis is really nothing to someone. That means that you just have an idea, which isn't true. And the theory to a layman is means that you just have an idea. So we have these two words that really mean nothing. And then as science communicators, we're saying, hey, this hypothesis turned into a theory. So what you're saying, and the layman hears that and they said, okay, so you had a brain fart and then it turned into a thought. Like that doesn't
Yeah,
make anything. Like what does
yeah,
that even mean? So I've tooled around with like a you know a experimentally proven hypothesis or a experimentally proven theory or something like that, where it's, oh, you can't say proof now, but you can't say proof in science, that's in anti-science. And it's like I think like we have to meet people where they are. I think that as a science communicator, that's really important is to not meet people where you wish that they were, but meet people where they are. Um, and I think that in order to, as a science communicator, how um, I try to meet people where they are and then bring them up to speed by talking about the things that really excite me. So, as a scientist, I get excited about certain things that people don't even know about. And I have to kind of explain to them, not only does this exist, but it's like Star Trek, it's like literally Star Trek, what we do in the lab. People would not believe. I mean, the mRNA lipid nanoparticle vaccines blew people's mind, but that's 1987. Think about that. What you guys don't even know about the latest nanotechnology that exists right now that I was doing in my PhD. It's like it's unbelievably cool. So, like imagine what was in 1987 and the technology that existed now, and then imagine the technology that exists now. Like that leap forward also exists and happened with nanotechnology, but yet we are still debated on like, is 1987 technology too new? You're like, what, dude? Like, what are you talking about? Like, what are you talking about? Um, so yeah, it is very hard. It is very, very hard in order to say it. But I think that as science communicators, I try to like use jargon, but then also explain it at the same
mhm,
time too. So if I say a jargon word, like I try to explain it in the same sentence so that it's really important that people have like keywords that they can Google or they can Wikipedia themselves. And if they wanted to go down that rabbit hole, they can learn. I think that that's really important. But yeah, I do feel like um, there are colloquial definitions of words that we just have to realize as scientists that's just what they are, and we have to. And I try to kind of like I guess I speak differently, like in an academic tense versus in a conference versus here, but I think that's good. It's very slippery slopey. Like you're right in the fact that you could be quoted out of context, that kind of thing, and like definitely, I mean, I'll do like my own edits and be like, oh my gosh, that wasn't correct at all. Like that feels so like silly, but streaming 4 or 5 hours a day for so long, that kind of just happens, and you kind of mold your language as you go on.
It must be very frustrating because you use all these words in your scientific community and everybody understands what is meant.
Hmm.
And then you go out to the hoi polloi and suddenly you're being judged on the adjectives that you're using. We said, no, listen to the full sentence. Don't
Yeah,
pull a word
exactly.
out of context. You know,
Yeah,
it's unhelpful. Right, I have one final question. It's a
hmm,
bit of a fun one.
sure.
So always save the fun for last. When my daughter was a preteen, she was obsessed with volcanoes. And she had this persistent question she kept asking. She kept bugging me to ask a scientist this question. And she was always frustrated that no one could say yes to her question.
Okay.
So her question was, is it possible for a multicellular organism to have a life cycle entirely within molten lava?
Is it possible? Yeah, I think so. Probably. There could be. Like, there's some extremophiles that are like above, they exist above the boiling point of water. I don't know if it's like if it's within, like, we've seen it, but I think that, is it possible? Is it theoretically like possible? Like, sure, I think that it could be. But I don't know if we've have any examples of that. I don't think. But you're gonna have adaptations to basically have heat shock proteins and to have things like that. This is delving into the world of astrobiology. So
Right.
astrobiology is the idea of like looking at different parts of the world and then surveying life there so that we could also see that there are life forms on other planets, and then surveying, like, based off of the examples that we have on Earth, what would that be on other planets. So some like super hot worlds or something like Venus that's been trapped by CO2 and blanketed by CO2, sure, I mean, it would be very different, the life forms, but yeah, there's extremophiles that, let's see, what's the hottest extremophile that's been known to exist. Let me ask Claude, what's the oops.
All right, it looks like
um
there you go.
yeah, so we'll have to see
Yeah, it was
the
just searching, David, but we're
yeah.
ready
All
for the
right.
wrap up any
Dogs
second now.
Yeah,
dogs are
no,
barking in the background. My apologies, but
yeah, I
yeah,
thought
I
you was
think
frozen. Sorry.
extremophiles are just extremophiles are awesome. I think, and it goes to show, that's again why I think microbiology is so cool of a field, is that there really isn't microbiology has the largest swing between different types of life. The largest swing of things that can exist in ice core samples, permafrost, and bacteria spores, or whatever, how they exist now, all the way to, um, here we go, 122 degrees Celsius. Methanopyrus candelari. It's a
Okay.
methanogenic archaea that has demonstrated cell proliferation at 122 degrees Celsius.
Toasty.
Yeah, so it's just all the different types of metabolisms, all the different types of life. It's so cool. Microbes are so cool in that aspect. Like, mammals kind of all have very similar things. We kind of like all exist very similarly, but microbes are not that way. Microbes are there's just like alien like life. One of my
Nice one.
professors, my biology professor, was like, if you're interested in aliens, just study microbes. You don't even have to go outside of the world.
We don't want that alien on Earth. You know the
Yeah,
one I mean.
yeah,
We don't want that one.
exactly.
Right. Thank you so much, Greg. You have been an absolute awesome guest. David will be extremely ecstatic from your appearance on his podcast. Skepticsandseekers.squarespace.com. You know the drill. David's already done it. Any further questions for Greg in the comments? I'll go through them. I promise I might not answer them, but I'll definitely read them all, and we'll get Greg over onto Still Unbelievable, and we'll have a bit more of a chat, and we'll sort something out. David, did you notice the door's still there? I've not moved house yet, but we're working on it. We're working on it. Anyway,
Nice.
thanks, Greg. You have been awesome. I need
Thank you,
to
guys.
scoot.
Okay.
Lovely.
All right, guys. Thank you so much. I appreciate you. I gotta go too. Thank you so much. I appreciate the chance.
Nice one.